Yes, this is the Starknet Basecamp 1.0. Of course, on Monday we looked at some of the things and we had some questions to go back with, some tests to go back with, uh, where we had questions like what do you understand by Cairo VM. So in case you did some research, yeah, to me Cairo VM was just is a specialized virtual machine tailored for executing Cairo programming languages or Cairo programs. So yeah, and then we had another question: what is the contract state in the Starknet smart contract? So that question is really a tricky question, but it shows how you've started to understand this Cairo. So a contract state is all about persistence. So um, as long as you know that a contract state you have persistent data. So for example, in Starknet, the contract state refers to the persistent data stored with a smart contract. So this plays a very big role in maintaining the state of the contract across different transactions, because we know that when you're writing to the blockchain in this to Starknet, uh, you can either, when you're having data, when you're interacting with the blockchain, you can either write to the state, maybe that means that you change the state of the blockchain, or you can read from the blockchain. That means that you don't necessarily change the state, but you just read information that has been stored. So having a knowledge of a persistent state gives you an edge in getting to know deep about the Cairo or other smart contracts generally. The third question was asking whether is Starknet an L2 or L1, and yes, I think that one can be answered by everyone. So we are going to be having a link where we shall register. So let me get that link and make sure that we have it here. I'm going to drop it in the chat. So this link will be what we shall use to determine our tendency when we are getting our certificates. And yeah, we are going to be doing other things to make sure that those that attend regularly will graduate and will be given priority in many things if there is an SPOK to be minted or furthering their projects. So a recap on what Mr. Josh covered on Monday. You can actually follow him on X at Josh Bossa, yeah. So about the Basecamp. The Basecamp is mainly looking at onboarding developers to Starknet, both those that have been developing in the ecosystem but in different areas. Maybe they have been developing on Ethereum and they want to shift to an L2, given that Starknet is one of the, is actually the best L2 with very minimal gas transactions but also very fast transactions, and also onboarding new developers to the entire Web3 ecosystem. If you want to venture into Web3, where do you go to? So we are going to have these 2 months of hybrid, our hybrid sessions, where we shall have remote Monday, Wednesdays, and Fridays at 8 p.m. East African time, and yes, we shall have, I think, every Saturday a physical meetup in an institution around Kampala. Yes, so I think, yes, of course, I've hinted about graduation. So the graduates will receive an SPOK, which is a proof of attendance of this base camp. This can help you when you want to travel for hackathons, like in real life hackathons. Stackhouse is the best of the organizers of hacks, and yeah, this is one of the things you can show that you know about Cairo, you know about the ecosystem. And yes, so for you to be considered an attendee, you must have 25% attended live classes. So we have already started some of the questions in our the first class we had, and in this class we are also we are going to get an attendance. We are going to have the link in the description. Then for you to be taken as a graduate, you must have 50% plus attended sessions live, and also a score of 50% plus in the questions that we shall have. For example, we have just had a recap on the questions that were asked in the previous live. You can also catch these sessions on the Central Code YouTube channel. You just go to the Central Code, you will have a recap of this session, so that in case you come in late, or in case there is something that you didn't get clearly well, you can grasp it. So there are creme de la creme, and creme de la creme simply means that those who are showing dedication, maybe they want to build products, they want to request for funding, they are showing a lot of interest. For you to be among those, you must have attended more than 50% of the live sessions, and also have scored 80% plus in the questions. So make sure that you register in the link that we are going to send. And yes, so today we start from there. So as yesterday we talked about Cairo, we say that Cairo was inspired so much by Rust, and a knowledge about Rust gives you an edge to know more about Cairo. Actually, Cairo programming language was derived from Rust. Yes, so, and it's not just that, but the infrastructure of Starknet is built on Rust. So if you want to contribute to the infrastructure, you want to contribute to sequencers like Madara, maybe you want to contribute to many of the infrastructure work in the Starknet ecosystem, Rust, you need to know Rust because they are built in Rust. But even if you want to learn building smart contracts, building on top of Cairo, building on top of Starknet, you need Rust to quicken yourself in learning Cairo, smart contracts, and other things that you can build on top. So this is why we start our sessions. Okay, so installation. So the best place to go to, there is install Rust. So when you want to install, I think the best computers to use with Rust, I can confirm just to what I've been using so much. Rust best goes with Linux and Mac OS. So if you want to use Rust on Windows, you have to go extra miles and have Linux subsystems on Windows. So yes, there is a guide on installing Rust, which I'm not going to go through, but I'm just going to peruse through. Yeah, getting started, toolchain, and you can go through this. You can go through tutorials, but there is also, if you don't want to install Rust and you just want to play around with Rust, I think there is an online editor. Let me see if I can find it here. So try Rust without installation. Here it's not showing it, but if you're on a Windows computer, there is a try Rust without installation. Okay, maybe I can try to Rust long .org. /line. Let me see if I can get that link. So you might say, for this session I don't have Rust installed. Yes, so this is let me copy this and put it in the chat. Yes, so you can, from here you can try Rust without installation. I think, yeah, this is taking quite some time. Let me see. Yes, so you can try running just simple things, look at execution. One thing that you really love about Rust is the compiler. So the compiler makes sure that it guides you, like it guides you, or it guides you of your code and things like that. So let me also look for the link for those that have attended to register. So this will be one of the ways we shall be tracking registration. Okay, so the link is on my Telegram, which I don't want to load here, but I will put it there in any way. I think this is it. If it doesn't open up, you can let me know, but I hope this is the link. Yeah, so we continue. So yes, that's a playground you can use, and now we can start to maybe build a program. So if you're on Linux, you can go to your folder, you can create a folder. I'm not going to go into that. Then go into the folder, and for example, if you're here, this is your folder. My folder is called rustdoc. You can come here, open terminal. Like very many people have ways they start coding. So in this session we are going to be using Visual Studio Code. So whenever I want to open Visual Studio Code in a folder, I come and open terminal and then write code dot. So Visual Studio Code is a platform where you can write your code. It has many extensions and has many things that it offers. So if you don't have Visual Studio Code, again, you can search on how to install it. Hopefully everyone has it. So let me go to my Visual Studio Code. Is the black okay, or we should change?
It's okay.
It's okay? All right. Maybe what I can do is let's try.
Maybe zoom in a little.
Okay. That's too much. Is that fine?
Yes.
All right. So want to, let me see, I think. So we want to see how we can create a new Rust program. cd. So cd dot is for going back one step. I think I want to go another step. So even here you can access your terminal and you create a document. So for this, it's our first Rust program. Let me say mkdir. So for creating a new directory, I want to call it maybe Basecamp 1. 01 or not 10.01. Okay, so then let me go to that folder. So when I create a folder, it comes in my folder. It's somewhere where I don't know. So it's here, Basecamp 01. So to go into the folder, I can just say cd Basecamp 01. So yes, we enter the folder, and then the way we create a new Rust program is by running cargo. So first, if you want to know whether you have installed Rust properly, mostly you can just run cargo -- version, whether in terminal or this terminal, and then if it brings you a version, that means that you have Rust installed. If it doesn't bring you anything, please go through the steps, watch a tutorial or two, or read through the documentation and get Rust installed. Yes, so I have Rust, so now I can say cargo new starter Rust. Maybe people always could say hello. Let me just say hello stacks. Yeah, so this is our first folder. So when you write that command cargo new, and if you want asking, it creates the folder hello stacks in the Basecamp, and then yeah. So if you are wondering where am I getting the commands, so the best place I can point one to is the Rust doc. Okay, so let me see, Rust programming book. Yes, this first one. So yes, this is the programming book, and we are going to be following some of these examples. Sometimes we shall be coming and perusing through and things like that. So we started by creating this program, and you realize that when we create the program, so this is the folder. When we create the program, we have all these files. Let me go into the folder right from here. cd hello stacks. So when I list the files, you see we have cargo.toml, we have cargo.toml.gitignore, we have the src folder. So if I go into the src folder, we have the main.rust. So main.rust, this is where we write our Rust program, and we have a default program which we can run. So if you want to know how to run this program, the main resource is here. You just go maybe hello cargo, and you go through a lot, so you can know how to create a new, what everything means, but we are going to go through it quick and simple. So we have also cargo.toml. So cargo.toml, I think it is Tom's language, I don't know. Toml. This is where we have the name of our program, executable program or whatever program, then the version, and then we have dependencies. So you will see these files will be similar to those that will be in Cairo. Yes, we shall just change a few syntax. So for us to run our program or to build the program, we can say cargo build. I think we have cargo run, cargo build. And when we build our program, there is something that comes up. In this folder, we initially had src, gitignore, and cargo.log. So we have the target. So in the target, this is where we we always have the executable and either exe or .d. Yeah, so this is where we have the executable, and then you also builds, and then you also find things that we call WASM and CASM. So WebAssembly language, this is where your executable goes in the target folder. And in Cairo we have CASM, which is Cairo assembly syntax something. So yeah, it is kind of similar. So maybe if I want to run my program to see whether my program has built, I use cargo run. And we are moving so fast. So you see that hello world is running. So if I go back to my src main.rs, Starknet Basecamp, and then save, and I go down here and clear cargo run building. So hello Starknet Kampala Basecamp. So this is simply just running my program. So if I want to test, there's sometimes when you want to test specific modules, it is cargo test, and then it will give you a result that is more verbose, that is more wordy, where you can see if you have issues where they're happening, and then test. Okay, zero failed, so this means that everything is fine. So we have done some starting bit of Rust, and as we continue, we've looked at this. So we can go to variables. One thing I can say in variables is, like other languages, here we have variables. So I can say let say x be assigned to 5. I don't know. Okay, then I can also say let me just print when the value of x is. So it can be x here, or I can put x in here. Yeah, that's a variable, but most of the time, so let me try to print this. I believe it might bring an error, but yeah. So most of the time there is like a hidden type, maybe u32 int, which we shall go to I think as we i32 like that. So it is just hidden, but yeah, it gives you the same thing. So if I say for example x is being assigned to 6, so this is not allowed in Rust because Rust obeys something called mutability and immutability. Immutability means that once you assign a variable value, that value cannot be changed. So let me try to run this and then see what the compiler gives us. One thing that is we really love from Rust is that the compiler helps you so much, like fix your code. So the compiler is saying here that cannot assign twice to immutable variable. So it's very clear, and then it shows you let x first assign to x. So if you want to have x to be assigned to y, we can make this a mutable variable. and by adding just mute keyword. So clear. So when we add the mute keyword and then we run, warning, hello stacks finished dev. So warning, just this is a warning, value assigned to x is never read. Yes, so it's saying that x, this 32 is never read. That's why here if we print the value, it gives us 6. So it's just a warning. So that's the good thing with the compiler, with the Rust compiler. But this runs. But then we can go deeper to this, and let me see how. So variable, we are on mutable and mutability. We can add on something called shadowing. So shadowing is signing an immutable value, and then you assign that same value to another variable. So maybe let me not screw things up. So we started with just let x and be assigned to 5. Okay, so we started with this. So if we want to do shadowing, you can have a situation where you can say let x be assigned to maybe x plus 2, x plus 2. Now this is allowed, so that means that this new value will shadow this one, but then this is not a mutable value. Yes, so a mutable value is changeable, but an immutable value, or a value that is not mutable, cannot be changed. So you just shadow the previous value, and if we run this, so this is how like we learn Rust, and it's the same manner in which we run Cairo. It's doing that back and forth. So hello Starknet, the value of x is 7. So I can repeat, if I just say x here without saying the let keyword, x is assigned to x plus 2. This is not allowed because x is not a mutable value. So if I say cargo run, I'm getting an error. Hope that has not confused us. But we shall see more things as we move on. Yes, let me see how the time is. So okay, I think this. So we also have constants. Yes. For constants, what you should know is that a constant should be should have a const keyword. So for this value, we have to have the let there, and constant, I can have the const keyword, and constants are mainly declared using capitals. So pi number, and then underscore. Pi number was it 3 something? Yeah. So this is the way we declare constants. Then we have more scalar types. So as we started by saying that every value you declare, every variable you declare must have a type. So it can be an int, a uint, and this was explained so much yesterday by Mr. Josh, who was taking us through it. So let me go through tuples, arrays, characters, and booleans. The best place we come to is here. So data types, I quickly go through the different data types. So we have different data types. Let me say and you have to have U32. So the data types are mainly in bit factor. So you have, let me say, if you have a U32, I32, they are floating types. So you have to put this F. But whenever you're declaring, if they are the same type, even if you don't put this, it's fine. But if they are not the same type, then you have to be explicit. Yeah. So we are going to look at, I wanted to look at more of structs. Okay, we can look at arrays. Wait. Why? Yes, I want to. So we can have a situation where we have an array, and I think it's the same in other languages, and then characters, booleans. So a boolean, we know that it could have something, for example, whether the page is loading, and by default is false. So boolean are always true and false. Then we can look at more advanced features like tuples, structs, and enums. So a tuple is like a collection of different data types. So let me say I want to collect, we can take this same example. Let me say I want to have a structure where I have an int, a float, and maybe a character, but in the same thing. So that's what a tuple helps us to do. Tuples are almost similar to structs, but a similar is a struct is also a collection of the different components that make up a thing. For example, you can say a man, a struct man, where you have the fingers, the head, or the email address of the man, then the number of times they log into the system. So you have components that are making up that man. Then an enum is a collection of things that are exclusive. For example, you could have a collection of shapes whereby you could choose a rectangle, a circle, and things like that. Yeah, I think I can really turn that into that. Maybe we can say, so for example, here we have fn main let tuple. So you see 506.4 and 1. This is I32. So and U8 1. So you can print the values of y. So this y will go to the float and things like that. So tuple can be accessed in that way. An array, accessing the array, you have the index. Yes, maybe this is something that I can talk about. So for example, if I want to access this second value, the index of the array starts from 0. So let me say if I have m, let m be assigned to y. If I want to access the second value, I have to have index 1. So what is index 1? Index 1 is, this is index 0, this is index 1, this is index 2, this is index 3. So this will help you when you're having a loop moving through the array. Yeah, this is the way we access the array. So if I print say println the value of m is so I had to be explicit on the float. So this is what Rust helps you very quickly identify your error and then you move on. Reduce your volume. So here when help is wanted, that means that this is a warning variable is loading should have a snake case. Oh, that's just, so this is the snake case way I'm used to camel case in JavaScript. But yeah, it's just a warning. So this is the good thing with Rust, you can look through the warning. So the value of m is 3. So as we've seen, the value of m is this index. That's how we access the array. Okay, I think we need to have let me see how we, okay, I would love us to have a break, but okay, so we are going to go to functions and then we have already seen a function here, which is function main. So in main we can call another function. Let me say we declare functions with the fn keyword. Great, and just call a function like we call it in other programming languages. Then we name the great function out of the main function. So most of this is if you've interfaced with other programming languages, then this becomes easy. So you can have print ln things are getting rusty. Yes, so that's how we can also call that function. I would love to go to, so when you want to return something, we use the arrow and then the type of what you would want to return. So maybe here I would want to return return a U32. There is, so you can return anything, maybe 10, or you can also write what you want to return without these curly braces. For example, I can just write 10 without the, not the curly braces, but without the closing semicolon. So this is also a way to return. Okay. If else is the same way, and then you can have the if conditions. So there is also for example here you can let a number, so you want to find whether this is 0, that means that the remainder when this number is divided by 4 is 0. Then we have the remainder when this number is divided by 3, then this, and then we can have a default statement. So the same as other programming languages. And yeah, so I was feeling that maybe we should have a break up at this moment. So we have our first assignment, which is convert temperatures between Fahrenheit and Celsius. So this will carry 5 points, and hope it will be done. So any questions so far? Any submissions?
I'm putting adding on the assignment.
So this is the assignment that we have. The first assignment. So to write a Rust program that converts temperatures between Fahrenheit and Celsius. Yes, so for example, this Rust program, if you give it a figure, it's always in Fahrenheit, it will return a figure in, or print to the console a figure in Celsius. Yes, it's an assignment. Of course, as we go on, we can make it more interactive and then have some quiz. We shall have some quiz just later on. Yes, I think we started at 15 minutes. We have around 15 minutes to close up. Was that clear?
Yes, thank you.
Okay, thank you so much. Could we have a break of 5 minutes or 2 minutes? How have you seen Rust as a programming language? Maybe I could ask. So far. Anyone can answer. There is Kasumba, Sam the tutor, Joseph Bossa, our lead. So for this, how have you found Rust? Is it tricky? Does it need a lot of attention?
Hello, yeah. Can you hear me?
Yes, I can hear you.
Alright. My name is Samuel and I'm glad to be part of this session. Yeah, I joined a few minutes back and when we were writing, saying I think some useful stuff. Yeah, I'm actually on my way to learn Rust and I find these sessions helpful. Thanks for all the
Okay.
That's my feedback for now.
Okay, that is great. Make sure that you register. I think I sent a link for these sessions. I think at the end of the Basecamp, we shall have some goodies for those who have attended. There is a certificate, an SPOK, I think. We have here, we have, yes, a participant. So a hackathon to win prizes, but we want to have teams. So attendance, for you to graduate, you should have more than 50% of live attendance, and we do Monday, Wednesday, and Friday. And then, yeah, you can be among creme de la creme. We hope after this we shall have hackathons. Also, those who graduate will have an SPOK. So I've shared the link in the chat. I encourage us to register and also to do the quiz. So we have to do the questions. In the first sessions, we had 3 questions in the previous session, which was on Monday. And then in this session, this is one of the assignments that we have been having. I think we shall have some questions.
I beg your pardon, where did you share the link? I've checked in the chat, this Google Meet chat and notes.
I think this form, if it doesn't work, then please get back to me. I think it is this form.
Okay.
Yes, I think it is that form. So if you don't have access, if something is yeah, so it has your email, last name.
Is there like a WhatsApp group for this session? So
Okay, what we have so far is the Decentral Code Telegram. I think.
okay, so I could join that as well.
And then if you, I think it is that one. I don't know if I've made an error in it, but I think it's that one. Oh, no. And then we also have the YouTube channel. So these sessions are always recorded. You can go back, see the questions that we are asked, and also go through, and then yeah, so that you come back to next session when you know there is something. Otherwise, I would love to continue. So we have talked about the if-else statement, and then we are here. So I want to go to one of the next things, and if you understand this concept, then many things become easy in Rust and in Cairo. So ownership in Rust. So ownership is very important. It makes sure that Rust can make memory safe guarantees. And why Rust? Rust is a low-level language. Sometimes people use it to program a hardware, also to program many low-level things. So this concept of ownership helps us to understand. So in ownership, we are mainly going to talk about stack and a heap. And what is a stack? A stack is like when allocated memory is defined. Let me say I want to allocate 2 GB of RAM for 2 GB storage for this smart contract, or for this kind of work, or for these tasks that are running. So when we want to allocate a specified storage, we allocate a stack, and the stack uses a mechanism called last in first out. Like the way you stack plates on top of one another, that the last plate the first plate you put down will be the last, and the plate you put up will be the first. So when you're putting things, or when you're putting data, or whatever process that you want to put in a stack, it's called pushing onto a stack, and when you're removing, it's called popping out. And these processes are so fast because it's a defined storage. The heap uses a different mechanism. So when you don't know how much of a storage you need, you can allocate a big size, and we call it a heap. And this size that you allocate, it's called allocation. You can put things anywhere in the heap. You can also pick things from anywhere. This makes heap data stored in a heap to be slow in execution or searching, because you're searching different data types. But then what exactly happens is, when you have a heap, you store the pointer to the heap in a stack, because the pointer to the heap is of a defined data type. So maybe if you're looking for something from the heap, um, this pointer will guide you to where that thing is stored, to where all that data is stored. So these are the different things. So we use a stack mainly when we know exactly the exact storage that we need, and we use heap when we know when we don't know what storage, but we want the storage to be preserved. So I can have an example of scope, because we have been looking also at ownership, and I think scope is the next. So yes, and maybe we'll go before we go further. So data on a heap is disorganized. Access in memory on a heap is slower than on the stack, because you have to use pointers to get to the data. These act as references to the data stored. Ownership rules. Each value in Rust has a variable that is called its owner. There can be only one owner at a time. When the owner goes out of scope, the value will be dropped. So this one of the rules is what I wanted to demonstrate. So as long as you get these ownership rules, but the main idea is what we have just explained. So let's say we have fn main, have a main function. So, and then say let x be assigned to 6. So scope, we can do shadowing. Scope makes sure that if that value is out of scope, then it is no longer accessible. So let me say I want to shadow x. So I can say the new value of x is, so you have seen shadowing in our previous value, that this value x is immutable, but I can declare another x as long as I use the let keyword, and it will shadow this one. So this will be a new declared variable. If I don't put the let keyword, then this gives us an error, because immutable values are not changeable. Yes. So I can now have a scope. For example, in many languages, if you just have value here, a value here, you can access it out of this scope, But here in Rust, you cannot access a value out of this scope. So maybe if I select x be x plus 2 and I print, then if I print x here, print ln, let me copy this, value of x is, so if I print also this value, the value of x in the inner scope is 18. So that means that once I get out of this scope, this value of x is dropped. So when I print again here, the value of x will be this value, the value of x before the scope, so which was this. So this was shadowed, so x plus 3 will give you 9. So that means that after the value of x is 9, yet in this scope, x will go from the outer scope and then shadow this to give us 18. So that's something I can use, a very quick example I can use to explain this, that when the owner goes out of scope, the value will be dropped. So instead of having 18 here, because it's out of scope, this x value was dropped. Yes. Many things you get to know like as you practice, as you read. The best place I can point us to, you're having just a few minutes, 1 minute to be precise. The best place I can point us to is the Rust Lang book. So you set the ownership, the struct, there are things that match control flows. Others are functions like in other programming language, but there are many things that you can keep learning from this Rust book, and then you can just transfer this knowledge in Cairo. Of course, you have to add other things, other new things like the field elements, and so on. But yes, uh, that could be it for now. And let me see. So now we have these questions. Is the stack slow compared to the heap?
I think the stack is the stack is lower than the heap. So I may not be able to explain it very well as of now.
Why do you think? Okay, we can first take that answer. Any other answer? Is the stack slower than the heap? And that's a good thinking. So the stack is actually faster than the heap, and the reason is all data that is put in a stack is put in a defined storage, and you don't need references to search around. So the heap has to search around, the pointer pointing to the data stored in a heap has to search around for that data, whereas in a stack uh, we know where the data is stored and it is a defined storage. So the stack is actually faster than the heap. So 2 is, can I use mute to declare a mutable variable? Yes or no?
May I?
Yes, it's very fine. It's okay.
Okay, so earlier I had my internet was acting up, but I responded in the chat, and my answer was yes, the stack is faster.
Okay.
And also for the other question, you can, though like you had said earlier, most variables are immutable. So, but yes, you mentioned it earlier during the class.
Okay, that is great.
So during the presentation you did mention that. Yes, I had given my response to both questions, but the part I wanted to ask was earlier when you said preferably you need to be having Linux to be able to program with Rust.
Yes.
So should we prepare ourselves to shift to completely realign with Linux if we want to be able to program on Starknet and Cairo and all that stuff?
Actually, initially, I used to use a Windows computer, but you see, these things of Windows subsystems for Linux, where you load like a virtual machine on top of Windows, makes the computer very heavy. So the easiest thing would be, if you can't shift, then you shift and just have a Linux operating system. Yes, you'll find it much easier, much more easier, especially with this programming. Because actually I tried it when I was starting. I was a Windows fanatic until it failed me. So yeah, I would urge you that if you can get Linux, Kali, Ubuntu, whatever, Fedora. Yes.
Thank you.
You're welcome. And don't forget to register. Also, don't forget to do the assignment. If there is nothing more, we can close here.
For me, it's a good evening. Thank you very much for today.
You're most welcome. Right, have a great time, have a great evening. Let's see us on Friday.